Now we're going to go back for drilling, and we're going to select the 1/2 inch drill from our library. 1/2 inch solid drill bit. Let's leave everything at default. It is a little slow, but I adjusted the feeds and speeds, and it cut pretty well at that speed. So we're going to select our hole features. So we want to pick the top chamfer, the hole itself, and the bottom chamfer on each one, because that sets the top and bottom of the hole. If you omit the chamfer on the bottom, it will not calculate the depth of the hole correctly. And you could always override it, but okay, we're going to go to the next tab. It's the heights tab. Stock top's fine. Feed top. We're going to go from hole top to hole bottom. We want the drill bit to break through. Okay, so we've got, it's the shoulder now. We'll take it to the full diameter. And we want to go a little deeper, so we're going to go, let's go 0.1. And so that way our drill bit is assured to go all the way through the part and clear any chips. Okay, we're going to have to watch out for this parallel. We don't want to hit the parallels. Okay, we're going to go to the next tab, and we are going to do a deep drilling cycle with full retract. Peck depth of 1/8 inch, and that's probably good. And we'll just leave that at default. And then we're going to go to collision detection. We're just going to leave that alone. Alright, so we should have our 4 drilled locations. Now they're still undersized. They're not material safe, but they're undersized. Okay, so our next operation is going to be to profile the walls on these, and we're going to use a 3/8 end mill for that, I believe. So we're going to go to 2D contour, and for this we're going to select from our library the 3/8 end mill. And let's pick the bottom edge of our holes, even though we're going to need to modify that to go a little bit deeper. Okay, arrows should be on the inside of the holes. We're going to go to the heights tab. We'll leave this all at default for the first few boxes. Our top height is not going to be stock top. The top of our cut is going to be selection, and we're going to pick the top plane of the part that where it actually starts, because it's stepped down from here. Otherwise we're going to cut air of each one of these. And then our bottom height is not going to be the selected contour either. We're going to go to selection again on that one, and we're going to pick the bottom of the part, because our selected contour is up here, not down where the chamfer is. So we want to cut all the way through the part. And on this we're going to go negative 10 thousandths. Okay, we went 100 thousandths deeper with the drill bit. I think that's okay, but we're just going to go negative 10 with the okay, and we're going to go to passes, and we're going to do a roughing pass on the sides, and we can leave the maximum step over where it is, I believe. And then we're going to do multiple depths. That's a lot for this cutter to take off. It's not removing a lot of material per side, but it's long. And we're not going to do 3/4 inches or roughing step depth. We'll do 0.25 since we're not removing a great deal of material. And we're going to do we're not going to do any finishing steps at the bottom. So we'll leave that at 0. We are going to finish only at final depth. We're going to rough the final. We're going to use even step downs. We don't need to worry about islands. We're going to check the smoothing box. And then we're going to scroll up and we're going to look at our step over. So our finish pass right now is leaving 37 thousandths. So we're going to do a step over of 0.01, which is 10 thousandths. And it should give us a nice clean hole. Okay, we're going to go to linking tab. I'm going to try leaving all this at default except for our vertical lead-in radius. There's not going to be enough room for one anyway. And we might need to play with these numbers to get it to generate. We want to keep the tool down. And we'll leave the rest at default and hit OK and see what happens here. Okay, it looks pretty good. We lead in, we have an arc in, arc out, and then it does our roughing cuts, and then it's going to do the final finish cut at the bottom. What I need to verify is, do we have enough flute length to do that? So this is 3/4 inch thick. Let's go back to our tool and select our tool and look at the data. Our flute length is an inch. If that's correct, we should be fine. Okay, so now all we need to do is do the chamfer around the outside edge. This is where Fusion gets dicey. It seems like every other update it changes how this tool works, and I'm not sure why. We got our 2D chamfer. We're going to select our chamfer mill, which is the one we used before, the 3/8 chamfer mill, 45 degrees. Okay, we'll leave all this feeds and speeds at default. We're going to go to geometry, and we're going to select our contours. At the time of this recording, this worked. And we're going to select the top. We're going to go to heights. We're going to leave all of this at default except for this top height. We're going to change that to selection, and we're going to pick the top of the part. We're going to go to the next tab, and this is where on this command, if the chamfer is modeled, you have to put chamfer width 0. The other two, I believe, you can leave alone. I'm going to put wear compensation. Occasionally I've had problems with that actually working. And then we're going to go to the next tab, and we'll leave all this at default. Okay. And it works. Okay, go figure. Half the time it's the top works, the other half is the bottom. There's also semantics about, if you have, say, the wrong stock selected, it'll keep you from cutting the routine. Alright, now we're going to move on to operation 4. Okay, so for operation 4, we're going to hide operation 3 vice. And then we're going to make the operation 4 vice visible. I'm going to flip it around so we're looking at it. Okay, so now we're going to just do the chamfers on this opposite side, which we can copy the routine from operation 3, and that's the only thing that op 4 is going to do. We're going to create a setup, we're going to create a new setup, and we need to go through this rigmarole again here. So we're going to set our stock as from previous may work, or we'll leave that alone. Our model should be the actual part, okay? That should be selected. We do not want model orientation. We're going to do Z-axis and X-axis. We're going to pick the top of our part. Just to be thorough, we're going to pick a line that's in line with X-axis. And we're not going to use a stock box point again. We're going to use selected point. And it actually is popping to where I want it, which is ironic. But we're going to put it on the right hand side of the part. The reason being is these holes were all cut referencing this face. So we won't be able to use our stop. We'll be able to use the same parallel heights. So the Z-axis and the Y-axis between op 3 and 4 will be the same. But the X-axis is going to be referencing the part on the right hand side. So you just have to probe that one face, and the rest of the offset can stay the same as operation 2. Okay, so you can try to select on origin, but it looks like it's already there. And then we're going to skip over the stock tab. we're going to go over to post-process. We're going to type in 7310.3, which is the third operation. And our program, it's 4. And our program comment is going to be op4. We're going to use work coordinate system 1. Okay, let's hit OK. We're going to change our title to op4. We're going to take our chamfer routine from the previous operation. You're going to right click and hit copy, or you can use Control-C on the keyboard. Select op4, right click again, hit paste, expand the folder. We should get the chamfer routine. And then we're going to right click on that, hit edit, and we can just select the tops of these chamfers. Oops, we need to clear our previous selections. Otherwise we're going to do the wrong side of the. So there's chamfer 1, chamfer 2, chamfer 3, chamfer 4. Heights tab. We need to change our selection, so it's not the face on the bottom. We're going to select the other face. And we're going to select in contours. And we're going to go to passes tab. We'll leave all this at default. Linking tab, everything at default. Hit OK. And there's our chamfer mills. Alright, we're getting to the end here. We just have the hole to drill in the end. Okay, so I'm going to collapse some of this down. And we're going to do operation 5. For operation 5, we no longer need this sketch visible. And we're going to deselect the sketches. We're going to make the current version of the vise invisible. We're going to go to the 5th operation. And on this, I am going to elect to put the origin way up here. Reason is, we load 2 parts and they're going to be in different spots with our current fixturing setups. So until we get better tooling, we want to base our origin at the top of the part. Over 8 inches, this is going to vary a lot. And so you have to take care to get this installed in the machine normal to the table. By putting the origin up here also, if you choose to go with thinner parallels that we have, it will not matter, because you're going to probe the top surface of this and 2 faces for a corner. Okay, so what we're going to do is we're going to create a new setup, and for that new setup we are not going to use model coordinate. We're going to use z-axis and x-axis. We're going to pick the top surface of the part, and then we're going to pick what's the x-axis, which is this line here, and it's not pointing to the right, so we're going to have to flip that axis. And then we're going to put our origin on it could be a stock box point or it could be a model box point. It doesn't really matter. We do want to, in this case, we want to select the part body, and just for posterity I'm going to put model box point. And in this case we can just select the corner because it's in the right place. Okay, so we're going to probe the vertical face, and we're going to probe the back face, and we're going to probe the Z will be the top of this. Stock from previous is fine. We go to post process. We're going to do 7310.5, 5th operation, op 5, and we're going to use work coordinate system 1. Now if you were doing multiple setups, say you had 4 vices set up or 5 vices set up, 1 for each of these operations, you would use different offset numbers for each one. Okay, we're going to hit OK, and we're going to change this to op 5. And then we're going to go and we're going to we're going to basically do 3 cycles. We're going to do 3 drilling cycles. We're going to do the spot drill with the chamfer mill, and we're going to do our drilling, tap drilling, and then we'll do our tapping. Okay, so we're going to go to drilling. We're going to use our same tool 15 3/8 chamfer mill. And we're going to leave that at default settings. We're going to go to geometry, and we're going to select the cone of the countersink on our heights tab. We can leave that at default, and our depth should be correct. We're going to go to the next tab, and we're going to change this to a deep drilling cycle so that it pecks. And our peck depth, we're going to set that at 0.06, 60 thousandths. We'll hit OK. Okay, next operation, we're going to do drilling. We're going to select from our tool library, the VF1 library. We're going to pick the 228 drill, which is the tap drill size for a quarter 20 tap hole, which is, I believe, is what this hole is. We're going to select that drill. We're going to go to the geometry tab, and we're going to select the cone of the countersink and the hole itself. We're going to go to heights, and we can leave these at default. We do want a breakthrough tip on the bottom, so we want to go a little bit deeper. We need a fully formed hole to the depth that the drawing had. And then this is a threaded feature, so the way Fusion models this, it's barely enough to get a bottom tap in there. So what we're going to do is we're going to make sure we don't break our tap. We're going to go deeper by 5 thread pitches. So again, to calculate that, this is a quarter 20 screw. So it's 1 divided by 20 gives us 50 thousandths. Multiply that times 5, and we need to go an extra almost quarter of an inch deeper, because the first 4 flutes on that tap don't actually cut anything. They progressively, or they cut something, but it's a progressively, it's cutting progressively with each tooth. That's just insurance. We don't want to hit the bottom of the hole. So on that breakthrough depth, we're going to put 0.25. Okay. We're going to go to cycles. We're going to do a peck drill. So it's a deep drilling with full retract. We'll leave that at default settings. Okay, so we've drilled into the part. Okay, next we're going to do our last routine, which is going to be, we're going to do a tap drill cycle. We're going to pick our tool from the aluminum library, VF1, and we're going to use the quarter 20 form tap. Let's select that. Keep the default feeds and speeds. Under geometry, we're going to select the same 2 hole features. We're going to go to heights. We're going to leave all this at default except for the whole bottom. In order to get a fully formed thread, we need to go 0.25 deeper with this tool. And in this box, we need to put negative. Now, we don't have a breakthrough tip on this tap. This tap has a blunt edge on it. What's going to happen is this cutter is going to go a quarter inch deeper than what our actual hole is. The fully formed thread will hopefully be to spec, but the bottom of the drill hole with the drill bit is going to go deeper by that breakthrough depth. So we won't hit the bottom. Okay, we're going to go to cycle. It's tapping. I'll leave it at default. Leave the next one at default. Okay, so what we need to do is make sure that this shank doesn't hit. So we need to double check our tooling. Alright, that's it. That's for the cam tutorial for the part number 7310, Rev 0, and it's the mounting block. Okay, thanks a lot, and I'll catch you on the next one.